Hello, this is Dr. Kraus with the first in a series of videos that I'm calling Python for Engineers. I want to use this as a kind of tutorial for my students for hopefully a while, kind of update it as necessary if new tools come out. But the basic idea is, how do I help engineering students who may have had some other programming languages taught to them get started using Python as quickly as possible. And in this first part, I want to do an overview. So I want to answer two main questions. Why should you consider Python for engineering purposes? And then what does it take to get started with Python for engineering? So when things that come to my mind as far as why Python. First, it's free and open source. There are no licensing hassles. You can install it on anything. It also runs on Raspberry Pis, which I think is really cool. It's cross-platform, all kinds of things. I think the syntax is exceptionally clean, and it makes it less painful to program than other languages. We're not, like compared to C, we're not always having to worry about curly brackets and semicolons and those kind of things. The syntax really does make for clean programming, in my opinion. It's also powerful and all-purpose. It's not just a language for doing specific mathematical stuff or just engineering or just plotting, but it can also be used to run web servers like in Flask or Cherry Pie. Lots and lots and lots of applications for Python. I think the combination of syntax and a ridiculous number of tutorials on the internet make it fairly easy to learn. And then others have referred to it as batteries included, meaning that all the libraries you could ever need and all of the scientific tools and so on and so forth are all available to you almost always for free. Anything that you could need almost. So lots and lots and lots of helper, like Python in and of itself is actually relatively small and maybe not even super powerful. But when you start adding in all of these free modules, you gain a lot of power. So what does it take to get started with Python? I think there are four main phases. You need to get it installed. Now, be very careful here. I don't mean, at this point someone's like, oh, I want to jump ahead. I Google install Python. I go to python.org and I'm done. We don't just need Python. We need all of the engineering and scientific tools to make Python really, really powerful. Chances are, especially if you're on a Mac or Linux, you already have a basic Python installation that just kind of came with your computer. But that's not enough for our purposes as engineers. So the installation can be a little bit painful, but there's also lots of people who want to help you with that process. And then phase two, I'm going to strongly recommend learning to use the Jupyter Notebook interface, and that's Jupyter with a Y for Python. And then you need to learn the basics of the programming language. How do you declare variables? How do you create your own functions? How do you do if, then, for, while, those kinds of things? And then how do you learn the scientific and engineering tools that we need to plot and analyze and deal with simulation stuff and do differential equations or just deal with matrices and arrays and those kinds of things. So as I've already said, installation is not just Python. We want scientific and engineering packages such as NumPy, Matplotlib, SciPy, IPython, Jupyter Notebook, so on and so forth. Those can be downloaded and installed individually if you want to install just the bare minimums to do what you need to do. That's going to be a little bit of a painful process. If you're running Linux, your package manager should have everything that you would need. And so whatever commands you use to install things from your package manager, so if you're on Ubuntu or Debian, something like sudo apt-get install python numpy should work for the numpy package. Then you would just have to find the matplotlib, IPython, SciPy, those kind of things. If you're in Windows, I would strongly recommend the Anaconda approach. That's a company that has just basically said, we want to help Windows users get all the scientific tools. Now, it's a little bit big. It's maybe 500 megabytes or something. I think it's like a 300 megabyte download. I don't know how big it is. So it might take 500 megabytes to 1 gigabyte of hard drive space to do Anaconda, but it's going to, because it's a lot of stuff that you might not need. But it's definitely everything that you do need and a nice little way to launch the server and all those kinds of things. So I would strongly recommend Anaconda for Windows. Mac users could also use Anaconda, but at this point a Mac user has to make an important life-altering, potentially, decision. Do you want to be someone who just kind of does the basic stuff with the mouse, or do you want to learn to be a power user from the command line? And so Mac users, in my mind, have a neat opportunity. And I'm coming from a little bit of a weird perspective in that I'm a Linux person who migrated to Mac, and so I'm used to using the command line. For a Mac, I would use Homebrew and pip, and that's what I have used, but Anaconda is a simple option. I am going to strongly recommend the Jupyter Notebook. If you've worked with other programming environments or IDEs or whatever, you might be used to, here's a text editor, and then over here is a different part where I actually execute the code, and so you have an editor and some kind of command window. I used Python in this way for a long, long time, so I would have the IPython console running in my terminal, and then I would have my text editor doing all my code editing, and then I would run the file every time I got done editing it. And I really was hesitant to break away from that. Lots of people were talking about the Jupyter Notebook, and I was like, that seems like it's kind of cute for new users, but I really wasn't going to do it. But then I had my students do it last fall, and I really liked it, and I started using it more myself for kind of everyday use. And so I really like the idea that you take a text editor and the command window, and you just kind of interweave them. So that it's a server that runs on your computer that's only visible to your computer, and you can, in that web page, paste in blocks of code or type in blocks of code, and those can be of arbitrary length, and so you could have very large chunks if you wanted to, and then the output of the last line automatically echoes. You can do a really clean inline plotting thing. We'll talk about that. Lots of good things about the Jupyter Notebook, and I think my students have really liked it. It's definitely clean and easy for new users, but even if you're someone who's been doing Python for a while, I think there's still value in it, and so I'm going to strongly recommend that. So once you have it installed and you know how to kind of open it up and use the Jupyter Notebook to start executing code, you need to learn the basic syntax of Python. You need to know how to declare variables. You need to know how to do for loops, if-then structures, like the basic programming building blocks. You want to be able to define your own functions and so on. And then eventually, as engineers, we want to work with vectors and matrices, NumPy. We want to be able to plot things. That's the matplotlib module. We want to read in data files, and we want to be able to do simulations and all kinds of other things. And so those are the basic topics that I'm going to cover over this series of Python for Engineer videos. We'll cover installation and in the next one, and then the Jupyter Notebook, and then we'll do some Python basics videos, and then we'll get into specifically engineering and scientific stuff. Thanks.